In this lecture, we are going to cover strings and file input-output. We've already seen strings in Matlab, which are simply a sequence of characters where each character is represented by an integer number, and the correspondence between numbers and characters are given in a table named ASCII. Okay? So the new line character, for instance, would be the number 10. And you see the line feed and its description. Some of these characters are not printable, meaning when you print it in the Matlab command window, you don't see anything. Sometimes you will see blank spaces instead of the actual character. The ones that you will see will be the digits, the alphanumeric characters, and some of the punctuations. Okay, especially the ones that are below up to 31 may not have any printable characters on the display that you will see. Okay, but when you convert them to a number, you can view that number. All right. So one character corresponds to one integer number. You can take a character string, which is an array of characters. So this is a row vector, and you can convert it to a double number, meaning a sequence of numbers. And these characters will be converted to numbers as defined by the ASCII table. So if you look up that table, the letter H corresponds to the number 104. Okay? The alphabet is given in sequence such that if you add 1 to the representation of A, you will get the letter B. All right. When you add a new line in a character string, it does not move the character string to a new row in your matrix, but when you print it, it will be displayed on the next line. All right. So here I'm taking the word hello, and after the first 3 characters, I'm adding a new line character. All right. So the number 10 represents a new line character. And then I'm taking these numbers and converting them to characters. Sorry, I'm taking these numbers and converting them to characters. And Matlab will display this string. And there's a hidden new line here that you don't really see, which makes Matlab command window move on to the next line, and then you see LO printed. Okay. But the vector representation of this character string will just be one row vector. Okay, you do not get a matrix with 2 rows. You have a single row where the 4th character is a new line character. Okay. Sometimes I will also write \n to represent a new line character. Okay, as you can also use \n to print a new line character if you are using fprintf function. Okay. In Matlab, you write character strings enclosed by single quotes, but sometimes you may want to write out the single quote itself, and you have to escape a single quote so that Matlab is not confused with the possibility that you are closing the quote, closing the string. So every pair of single quotes will be replaced with a single quote before it's being stored in a vector. Okay. So when you say message equals single quote Ahmed's, a pair of single quotes, presentation, and end with a single quote, this pair of single quotes will be replaced with a single quote. Okay. Clear? All right. Okay. So let's write a Matlab function that will return a random alphanumeric string of length n. So if I say strrand2, I should get, for instance, A, B. Or strrand3, I should get, since it's saying alphanumeric, I should also include some numbers in here, 3Z, 5. Okay, so basically I'm trying to generate a password, a random password that has length n. The solution is up there. So the strategy is the following. I first construct a vector of characters that I will pick from. And that's the string S. And it contains the characters, the lowercase characters A to Z, uppercase characters A to Z, and the numbers 0 to 9. Can you see this function on the web currently? I mean on the course web page? Let me put... Okay, after I construct this vector S, it will contain all the lowercase characters, all the uppercase characters, and digits. And I will randomly index this string S. Okay? So S is a long string that contains A, B, C, all the way to Z, because I use this colon operator. And then capital A all the way to Z, capital Z, and then the digits from 0 to 9. So this is string S. I can take the length of this string, which is how many? 62? Is it 62? No. Yeah. So let's do that. Copy paste in the command window. S, numeral S. So it contains 62 characters. And then you randomly generate numbers between 1 and 62. And you use these random numbers to pick randomly from this string S. To generate random integers, you can use the rand_i function. So rand_i 62 will give you a single random number. Every time you call that function, it will give you a new number. To generate more than one random number, I will give the matrix, in matrix notation, one row, let's say 10 columns. So this will give you a vector that contains one row and 10 numbers. Each of those numbers will be random integers generated between 1 and 62. Okay? So every time you call that, you'll get a new set of random numbers. And I will use these random numbers to index the string S by simply putting it in the parentheses, following S, and you get a random password generated from the string S. Okay? As done here. So instead of 10, I have n, which is provided to this function, and instead of 62, I have numeral S, which will be replaced by 62 in any case. So let's test this function. strrand5 will give me a random password with 5 characters. strrand10 will give me a random password with 10 characters. Okay, any questions? Yes?
Then putting S, right, like would be in the command window, putting S, and then whatever you wanted would put it together, we put all those numbers.
All right, so the question is, how did I know that if I index S as, in this case, will give me those letters or numbers? So S is a vector, okay? Just like any matrix, you can select elements of a matrix by indexing. The indexing can be either numerical indexing, in which case you need to provide the row number and the column number that you are selecting. In the linear indexing case, which is considering a matrix linearly, then you only need to provide a single set of numbers. Instead of rows and columns, you just provide, let's say, the columns. Okay? So if you provide a vector of numbers to index a matrix, you will pick, using linear indexing, the elements corresponding to the indices that you are picking. Okay, so let me draw it here. So S is a vector. All right, and then you can construct any vector. Let's say 3, 5, 1. Let's call this X. And then if you say S sub X or parenthesis X, then you are picking the third, fifth, and first element out of S. All right? And initially we had A, B, C, D, E, F. So the third element will be C. So this will generate C, fifth element E, and first element A. All right? So the first step was to construct this vector S in the first line. In the second line, I am constructing this vector randomly from numbers between 1 and 62. And I'm generating n such numbers. And then I'm using these to index this large string S, which will give me a random string each time. Okay? Yes?
So if you do like X and C's like colon, like how do you want to like colon?
So let's see. So the question is, what happens when you use colon inside the parentheses that when you are indexing S? So I open the parentheses and then let's say 1 colon 5. Is that sort of the question?
No.
No?
So it would be like colon 5.
Colon comma 5?
Yeah.
Okay. S colon comma 5. Since S is a row vector, you are picking all rows. There's a single row, so you are picking the first row.
Right.
And the fifth column, so this will be equivalent to just saying S5.
So instead of doing 5, if you did everything you did in the center of S, you just put the colon and the comma?
Yes, that should work too. Yep, it'll do the same thing. Let's just try it. Colon, comma, and you get the same effect, okay? Since you have a row vector, meaning you have a single row, you don't have to use colon, comma. Colon means pick all rows. Since you only have one row, you don't have to write it. And because we are using linear indexing, you don't need comma, all right? So you can also do this. From the first row, comma, pick random columns. All right? Any other questions? All right. You can concatenate strings just like you concatenate vectors. You use the square bracket notation to generate a new longer vector. And likewise, you would use a square brackets to concatenate strings or character arrays. So in this case, I have 3 strings, Ahmed, a space, and Sachan, and then I enclose them with square brackets to generate one long string, okay, with a space in between the 2 words. You can also use the strcat function, which does exactly the same thing, and you will get a longer string. You can also use the sprintf function. Sprintf works just like fprintf, except that instead of printing into the command window, it works as a function that returns the generated string. Okay? And Matlab will print it because I don't have a semicolon at the end. Question?
What would be the benefits of using like strcat versus just the vector notation? Would it be the same thing?
So what's the benefit of using strcat compared to the vector notation? Nothing. It's just personal preference.
Oh.
Okay.
Or even the sprintf?
Sprintf will provide you more power than just concatenating because in this format string, you are not limited to %s. You can also print numbers.
So what is that first argument doing
Okay, in the sprintf or fprintf, they work very similar. The first argument is a format string. Anything that does not follow %s will be printed literally, meaning it will be printed exactly. The % sign is a special sign for sprintf and fprintf, and the character following the % sign determines what data type you are printing. %s stands for a string. The first %s will be replaced with the second argument to this function. So the first following argument. The second %s will be replaced with the third argument, and the third %s will be replaced with the last argument. So each % sign will go and look at the next argument and will be replaced by that. So if you had instead of a string, you could also write down, let's say instead of Ahmed, I have 35.7. Okay, so this will generate a string, no longer a number, where you are converting. Let's say this is %f dot 7, and then space such. So you are taking a number and converting it into a string, meaning you take the decimal representation and you allocate one character for each decimal place.
And that's %f.
Yes, %f. And you cannot do this using the vector notation. If you did the same thing using vector notation, I think Matlab will give you an error. Let's say 35.7 such on. Okay, it did not give me an error, but it will replace 35 it will take the 35 as a single character. Okay, using the ASCII table.
So the %f, that corresponds to
a floating point number. So you print a floating point number, it'll take the 35.7, the number itself, and show it as if you would print it on a paper. Okay, it does not take the ASCII table representation, it takes the numerical value and print that.
But it's still returning a string.
It still returns it as a string, okay. Yes.
So I guess that's what I'm confused on. It like corresponds to what format you want your input to be.
Right, so the first argument, you use the first argument to control the way the numbers, the strings are printed. Okay? And then the following arguments are the things that you print. Each % will be replaced with one of those arguments. Okay? All right. In addition to data type, you can also control the width that number is being printed. For instance, if I say %5D, and then let's say instead of Ahmed, I have number 10, then Matlab will allocate 5 characters to print the number 10, and then followed by space, such on, assuming the rest are the same. Okay, so saying %5D, you allocate the width of the thing that you are printing.
So you're going to want 3, so it's going to put 3 spaces.
Right, yeah. You'll try to fit your number into 5 characters.
And it's always going to shift it to the back of the 5?
I believe so. So I put these pound signs so I know where the spaces are. It aligns to the right. All right? We already saw multiple strings when we covered cell arrays. One way to construct multiple strings is to just construct a matrix, and Matlab will enforce these words or these strings to have the same length. So when you use the character function, you will get a matrix, and the shorter words will just be appended with spaces so that you have a proper matrix. Okay? So this is a 3x5 matrix where the first row contains the characters hello, and the second row contains the characters yes and 2 additional spaces. Okay? A more convenient way to deal with strings is to use cell arrays, as we saw in the last lecture. In this case, Matlab will not pad your words with spaces. The words will be stored as they appear, as you enter them. So in this case, messages 2 will just be yes. All right. When we were covering indexing of cells, there was a distinction between a parenthesis and curly brackets. When you are using parentheses, you are generating a new cell array. Okay? You are not opening the box and taking the contents out. You are generating a new cell array. So messages parenthesis 2 will give me a cell array, and if you enclose that with square brackets, you are concatenating cell arrays. So as a result, you will get a new cell array that contains 3 elements: a pound sign, the word yes, and another pound sign. In the next example, I used the curly brackets, so I'm extracting the contents of the messages 2, which is a character string yes. So this is equivalent to saying square brackets, pound, yes, and then another pound. And these character strings will be appended, will be concatenated to generate a single string. And this example will give you this, pound sign, cell yes, and then another pound sign. Because you have a cell, the concatenation with the other elements will give you a new cell array. Okay? Similar to matrices, you can construct a matrix of cells. You are not restricted to a single row. And we just use semicolon to move on to the next row. There are a number of string functions. I'll just cover some of them. The lower function will take a string and return the same string converted to lowercase. So all the alphabetical characters will be converted to lowercase if they are uppercase. If they are lowercase, they are not changed. So hello space 123 gives you lowercase hello 123. Similarly, the upper function will take the string and convert all the lowercase characters to uppercase. This character function will tell you whether a string is a character, whether it's a character data type. So is character 20 will give you false because 20 is a number, even though you can convert 20 to its corresponding character. Okay? So is character is a data type function. It tells you the data type for that variable is a character. And let's say x equals character 8, or let's say x equals character 9, to be slightly more confusing. And let's look at the workspace. And you can see, you cannot see yet. Let me show the data type column. Yes. All right, so you can see that x is a character, all right? And the isChar function will just tell you whether the data type is a character data type. Is character x will give you 1. Let's say x equals number 9, and in the workspace you see that now it's a double. It's just a number 9. And is character x will give you false. All right? You can convert the number 9 to a character and then use the isCharacter function, which should again give you a true. all right? Because you go from the smallest element, smallest expression that you can evaluate it, replace it with the result, and then move on to the larger expression, all right? IsLetter function will give you, will tell you whether the characters in a string are letters or not, whether they're alphabetical characters. And you will get a new logical vector that has the same size as the input string, and you will have a 1 wherever you have an alphabetical character, wherever you have a letter, and 0s everywhere else. This space will give you a true wherever you have a space character. All right. So given a string, you can split it into words by first identifying where the spaces are, and then taking the rest and converting them to a cell array. So that would be one strategy, to convert a string into its words as a cell array. Okay. To generate a number of blanks, you can use the blanks function. So this will give you 5 blank spaces. You can also use the repmat function that we saw, that replicates a matrix. So the equivalent of this blanks function would be repmat, a single space, comma, 1 rows, 5 columns. This will replicate the given matrix, which is a single character. Along the rows, you replicate it once, meaning you don't replicate it, and along the columns, you replicate it 5 times, which will give you 5 blank spaces. dBlank will remove the blank spaces at the end of your string, and strtrim, which stands for trim a string, it will remove spaces from both ends of the string, and neither of these two functions change anything in between in the middle of your string. So they only operate on the ends of your string and remove the spaces. Okay? Comparing strings is slightly more useful. So when you read an input from a user, or when you read a word from a file, you would need to compare it with something that you are looking for. You can go character by character and ensure that each character is equivalent to what you are searching, or you can use the strCompare function, which will do that for you. strCompare function takes 2 strings. It returns true whether those 2 strings are identical, and this identity is done case sensitively, so a small letter A will be different from capital letter A. If you want case insensitivity in comparison, then you can use the strCompare I function. The I at the end stands for insensitive. Okay. If you are only interested in comparing up to a certain number of characters, you can use strNCompare. So you are only comparing the first n characters of the 2 strings. And there's a corresponding strCompare I, which compares the first n characters but does that insensitively. Some examples are given here. strCompare yes, yes. Since the 2 strings are identical, will give you a true or a 1. And then strCompare yes, no will give you a 0, a false. And then you are concatenating these 2 numbers into a vector, which will give you a logical vector, true and false. The next example, you are comparing small letter yes with capital letter yes. What will it give me? True or false? False, because Matlab compares case sensitively, so this is a 0. Next example, true, because strCompare I does it insensitively. Next one. It'll be true. You are first taking each of the inputs and converting them to lowercase letters, lowercase words. So the result of this will just be small case yes, and the result of the second argument will again be small case yes, and the result will be true. The next example, false. There is a space character, which will result in false. Next one, true, because I'm first removing the blank spaces, which will result in yes, and then comparing the two words, which will give me true. All right, let's write a function is prefix s that takes two input arguments and returns true if the pre is a prefix of the first string. All right, so s will be the first string, and pre will be the second string. So first, let's consider, let's make sure that the pref variable is shorter or the same length as s. Otherwise, we'll just return false. So that's easy to check. So that'll be our first check. If pre is shorter or the same length as s, we want to make sure that each of their corresponding characters are equivalent, are identical, and we will only compare up to the length of pre. Okay, we don't really want to consider whatever is left in the string s. Let's first do it using if statements, and then I'll show you how you can combine it into a single logical expression. So if the length of pre is less than or equal to the length of s, then I will compare up to n characters, because I only want to compare the length of pre, not the whole string. So the third argument to strn compare will be the length of pre. And then if so, I will set out to be true. And otherwise, I will just set a default value for out, which will be false. So given two input arguments s and pre, I am first setting the default value of out to be false, and then the first if statement checks whether the length of pre is less than or equal to the length of s, and if so, it moves into this inner if statement, which compares the two strings up to n characters, in this case n being the length of pre, and if those are equal, then the output variable out is set to true. Okay? All right. So I have two if statements. I can combine them using ands. So if the first condition holds and the second condition holds, I will set out to be true. So this will do the same job. Let's reduce this further. I have an out variable that contains false, and it contains true only when this expression is true. So essentially the value of out is the same as the result of this expression. So I can replace that by just saying out equals that expression itself. All right? So the value of the out variable will be true whenever this is true, and it will be false whenever that's false. So the value of the out is exactly the result of this expression. All right? Any questions? All right. And let's replace it with that. And I just broke it into 2 lines by using 3 dots. Let's test it. Is prefix apple AP should give me a true. Apple 2 should give me a false, since the second string is not a prefix of the first one, and it fails at the first condition without even getting a chance to evaluate the second expression. Yes?
You need to add the numeral condition if one is greater than the other.
So if pre is greater than the other, then this will not be satisfied. So this will be false.
But won't you get a false anyway if pre is longer than s?
If pre is longer than s, then let's just remove it. Remove this. Save it. Is this what you mean?
Yeah.
Okay. Let me just repeat the example that I just wrote. That works. Okay, so the length would be handled inside the str compare function, so it works too. So you don't need to additionally check the length. If you replace this with your own comparison, then you do need to check the lengths.
Right. But if you don't use that.
Yes.
Yeah, if you don't use that function, then you
Right.
need that.
Okay. All right, so this would be replaced by S1 to numeral pre equals pre. All right, and then we want to make sure that they are all trues. Since that's a vector, you'll get a vector of 0s and 1s, and you want to make sure that they all line up and end up to be the same thing. So it again works, but when I do this, I can no longer delete this, because if I do, Matlab will give me an error, because I don't have enough characters in S to extract using this expression. All right? Any other questions? Okay, so str and compare essentially does this this check with additional checks to make sure that you have enough characters in both strings. All right, so far we only compared 2 character strings. You can use these functions to compare a set of strings, a cell array of strings. So if the first argument is a cell array and the second argument is a single string, then it's similar to performing addition of a vector with a single scalar, and this will be compared with each of these strings. And as a result, you will get a vector that contains the comparison of the second argument with the first string and the second argument with the second string. Okay, so you'll get 0, 1, 0. If you have cell arrays as both arguments, then you need to have the same number of them. And the first one will be compared with the first one, the second one will be compared with the second one. And this example will give you 1, 1, true, true. Okay? If you have a set of strings and you want to figure out which one matches a given second string, you can use a find function to pick out the location within the cell array of the string that matches the string that you are searching for. So in this case, str compare will give you a vector that contains 0 and 1, and then the find function will take this and give you the number 2, because the second element contains 1. All right? Good. So when you compare strings, you compare them as a whole. All right, so you make the str compare function will take two strings and tell you whether they are as a whole equivalent or identical. In some applications, you would want to search for a smaller string within a larger string. Okay, and we call it finding strings. For that, we will use the str find function. We have a haystack, which is the larger string, and a needle that we are searching for, which is a smaller string. In this example, we have a string that says find the starting indices of the pattern string, and the needle that we are searching is the in word. Str find will give you the locations of the matches. Okay, so wherever you have a match, you'll get the index of that location. So there are 4 occurrences of the word in this larger string, starting from the 2nd character, 15th character, sorry, this is the 15th character, 19th character, and the 45th character. Okay? You can provide a cell array as the first argument, and if you do so, the second argument will be searched against each of those strings in your cell array, and as a result, you will get a cell array where the first cell element will contain the indices of this word would in the first string, and the second cell array will contain the indices of the would in the second string. So in the first string, the word would occurs at the 10th character and 23rd character of the first string. And the word would appears in the 6th character and the 28th character of the second string. All right? So let's work on this exercise. We would like to replace all of the small letter O with capital letter O. And we will do this using 2 different methods. One of them will be using vector indexing, and the other one will be using str find function. All right, so you can take a minute or two to work on this, and I'll give you the answer. So if you are sitting on the right half of the class, you can do part A. If you are sitting on the left half of the class, you can do part B. First part, in the first part, we are asked to use the vector indexing. So let's take this string S. First, I need to identify the locations of the small letter O. And I can do that using equal sign. If I say S equal small letter O, I'm comparing a vector that contains hello world with another vector with a scalar that contains the small letter O. And it will give me a new vector, a new logical vector that has the same size as S, and it will be 0 wherever it does not match, and a 1 wherever there's a match. Okay? So you get a true-false map that tells you where the small letter O is located. And then I can take this logical vector, and use it as an index into S. Okay? So this map will be overlaid with the string S, and I would be only operating on the portions of S that contain a true in this logical vector. So I would be indexing only the letters O, the O letters. Okay? And I will just set them to capital O. So the answer to the first part is saying S, parenthesis, S equal small letter O equals capital letter O. Okay? And I can also replace this equal with str find. which will give me the same result. But strFind gives you a numerical vector instead of a logical vector. It will give you the locations of the letter O. So strFind S, comma, small letter O will give me a vector 5 and 8. And I can use this to index S and set it to be capital O. Okay, so the answer to the second part is to just say S, parenthesis strFind S, comma, small letter O equals capital letter O. All right? Any questions? Okay. Replacing strings. So in the previous example, I replaced a single character. All right? If you wanted to replace a larger set of characters, a word within the larger, within your string, then you can no longer use the equal sign. Let's see why. Let's say I have the string S containing hello. Let me move this down. S equals hello. And let's say I want to find the locations of LO. S equal LO will give you an error because in most MATLAB operations, you can either compare vectors or matrices that have the same size, or one of them should be a scalar. Or at least one of them should be a scalar, in which case it will be compared or operated on with individually with every element of the other matrix. And the character operations work the same way. So I can say S equal small letter O. I can say S equal small letter L. I could also say S equal let's say apple, which will work also. Okay, so if they are the same length, the first one will be compared with the first, the second one will be compared with the second character, and so on. If one of them is a scalar, meaning a single element, it will be compared with each of the other one, each of the characters of the other one. All right. So this example shows that I cannot use equal sign to find locations of a string that's more than one character. You could use the strFind, which will give you the locations of LO, but then you need to additionally consider the length of the match. Okay, so you would replace only 2 characters of the original string. But you, instead of that, let's not bother with indexing. We can just use the strrep function, which will take an original string, meaning a large string that you want to find the old string inside, and replace all of the occurrences of the old string with the new string. An example is shown, flow crow. Inside that string, I will replace all of the OWs with the letter Y. And it will give me the string fly space fry. Okay? Any questions? So a lot of these are simple functions, but you sort of need to know that they exist and be able to use them when you need them. When you have a large string, you may want to find occurrences of a small string and split it by that small string. Okay? When you store your data file as a comma-separated file, which is like a spreadsheet, each cell element, each entry would be separated by commas. So let me give you an example. Let's open Excel. Let's type in some numbers for Excel does not. 5, 10, 20, 3, 6, 7, and then I will go to File and save it as a comma-separated file. CSV, comma-delimited file. Let's save it in the desktop. And let's open it in Matlab editor so we can see its contents. If you open it in Excel, Excel will just show you the spreadsheet. You can open it in a text editor to see the contents. Okay, so this is how Excel saved the numbers that you typed as a comma-separated file. The regular Excel files are not human readable. They are written in binary format. So you cannot easily read them, read the contents. You have to have the Excel program or a compatible program installed on your computer to view the contents of a spreadsheet. But if you save them as a comma-separated file, it's human readable, meaning all the characters in there will be ASCII, alphanumeric characters or other characters that you type in, but they will all be printable. Okay. All right. So given something like this, you would want to split it into numbers, meaning you want to split it by the comma character. And that's where the splitting comes into play. If you have a string and a delimiter, the default delimiter is a space character, but you can also specify other delimiters, such as the comma. But the default one, if you don't provide anything, will be a space character. If you provide a string, it will be split by the space characters, and the word up to the space will be returned. If you also want to capture the rest of the string, you can capture it as a second output argument. So the talk will contain hello, the rest will contain the space character, and the rest of the string. So the space and then dash. If you provide something other than the space character, you will be splitting by that. So in this example, I get hell and then O space dash. If your original string was hello comma dash, and you split it by a comma, then you would get hello as the first output argument and comma there as the second output argument. Okay? Question? Yes. So whatever you put as the delimiter tells you where to stop. So it'll stop at the first occurrence of that delimiter. Okay. You can also do this yourself in multiple steps. For instance, if you did not have this strtalk function, you could do x equals strFind string comma delim. That will give you all the occurrences of the delim inside the string. And then we would additionally say x equals find x comma 1 to pick the first one. Or let's, sorry about that. That would not be accurate. Let's just say x parenthesis 1 to pick out the first one. And then you would do string 1 colon all the way to x1. So all the way to the first occurrence of that minus 1 actually if you don't want to include it in your output string. So this will give you the same result as this hello. Alright? But you also additionally need to check to make sure that there is at least one match. If there are no matches, then x will be empty. Alright, so if the delimiter does not exist in the string, the strtalk function will return the entire string, I believe. Let's just check to make sure. strtalk hello, comma, x, and you get the entire string. Okay, any questions? normally you type your commands in your files or in the command window and you evaluate them. In some cases, you would want to create the commands on the fly. All right, meaning you would want to construct your strings, the contents of your file or other commands or the functions that you would be running on the fly, and then have MATLAB evaluate it dynamically. The eval function will do that for you. You provide a string to the eval function, and MATLAB will evaluate it as if you typed the contents of that string in the command window or in your file. Okay. So I could say x equals fprintf open parenthesis 2 single quotes hello 2 single quotes close parenthesis semicolon close the single quote, and then say eval x, and MATLAB will run this command as if I typed it directly. All right, and it will print hello. So eval in single quotes 2 plus 2 will print false, will print 4. And we haven't really seen the plotting functions, but this will generate a plot of the numbers x. Let me quickly go over a simple plot function. 2, 4, 6, 7. So you will get the values 2, 4, 6, 7 plotted against the x-axis, which will be numbers from 1 to 4. And you can write that expression in a string, and MATLAB will evaluate it and perform the plot. Here I am constructing a function called the plotWhat, where its value contains the sign function. So this plotWhat will be replaced with sign, and I will get a plot of numbers from 0 to 10 with a step size of 0.1, and their sign with a step value of 0.1 also. Let's try that. Let's try it without the eval function. I'll just copy and paste this. So I'm plotting the sign of numbers from 0 to 10 against the numbers themselves. And you can see the plot. So it's a sign plot. I could also enclose the entire thing in a string and pass it to the eval function, which will result in the same plot. Okay, since the plot did not change, you did not see any change. I can construct this dynamically, so I can construct, let's say, cosine. I'm appending different components, different strings to construct a single evaluated string. And I could also say x equals tangent, and then replace that cos with the value of x. Okay. All right. Any questions? When you are dealing with strings, you would often want to extract numbers from them. All right. So when you have a text file, such as the comma-separated file I showed you, it would contain numbers that you don't want to operate on them as strings. You want to take them and convert them to their floating point or numerical representation. So if you have the string 35.6, you'd want to convert it to the actual number, or the other way around. You would want to take the 35.6 and generate a string where the first character is 3, the second character is 5, and the third character is a point. Okay. We already saw that we could do this using sprintf function, so I'm not going to cover that. There are other sort of convenient functions that you can use. Num to str will take any number and print its string representation. Int to str will convert an integer and return its string representation, so the number will be rounded if it's not a whole number. Mat to str will take a matrix and return the matrix as if you would type it in the command window. Okay. So I'm taking this matrix and generating a string from it. Okay. These would be useful when you take your data in your functions and store it in an external file that you would like that you can later share with somebody else. All right, going the other way around, you can use the str to num function. So now I'm taking a string and converting it to a number. If it supports a number of different string formats, so if you have a single number, you'll just create a double number. If you have a number of numbers separated by commas, you will get a row vector. If you separate them by semicolons, you will get a column vector. And you can also use some of the things that you can use in the command window to generate vectors, such as using the colons operator. Okay, and the square brackets in the string is implicit. So when you use the str to num function, you do not need to put square brackets in your string. You can also use the scientific notation or other MATLAB functions which will be evaluated to generate numbers. Okay? Alright, so some examples are shown here. So here I'm not using str to num function, I'm using the more limited str to double, which is faster and it's sort of safer because you are not really using all of the functions in MATLAB. You are only restricting to extracting a double number from a single double number from the string. So all of these will give you results as expected. If you provide a cell array, you will get as a result a matrix that contains each of those numbers. Str to double, if you provide a vector in the string, you'll get another number. Okay, so str to double is not as powerful as str to num. It expects a single number in quotes or in a string. If you provide something more than that, it will give you not a number because it cannot handle it. If you want to parse more than one number, you should be using str to num function. So when we took numbers and we printed them into strings, we were using sprintf or fprintf functions. Going the other way around, you can take a string and extract numbers from it using scanf function. Okay. Again, the first argument is a format string. So you specify how you expect the string that you will be parsing to be formatted. It's very similar to sprintf. So each % sign will correspond to the thing that you are trying to parse. So sprintf will generate this string, and you can, if you know the location of your number, you can use indexing to extract it out. Okay, so this from the 7th element all the way to the 15th element will give you this 63.5 followed by zeros. And then you can use str to num function to generate a number from it. Okay, so you are generating a double from a vector of strings, a vector of characters. Okay. So if I were to ask you to write the str to num function itself for only integers, how would you write it? So let's, to understand this better, let's actually write an int to num, int string to num function. Edit int string to num. So we'll write this function such that it will take a string and convert that string to its integer number. And it will assume that the input is an integer number as a string. So function int str to num s. So if s contains 456, this is a string. I want the number 456 to be extracted from, to be parsed out of this string. Okay. So how can I go about this? So since it's a decimal representation, I can first find its length. So let's say n equals numeral s. Okay. And then I will keep track of my the number that I'm going to multiply by. So let's say I equals 1 first. Or another way of doing it is to generate powers. 1, 10 to the power 0 all the way to n minus 1. So if n is 5, then this expression will give me numbers from 1 to 10,000. So I'm generating powers of 10. So 10 to the power 0, 10 to the power 1, 10 to the power 2, and so on. Okay? So S was a string that contained, numbers 456, and I first stored the length of S in the variable n, so n will be 3. And then I constructed a vector that contains powers of tens, and then I will line them up with the numbers itself. Then I will multiply the digit inside S with its corresponding power and then add them up. Okay? That's my strategy to convert a string into an integer, All right, so since this will be 0 to all the way to n minus 1, let's go from n minus 1 to 0 with a step size of 1. Or you could also do flip left right so that you get numbers from 100 to 1 instead of the other way around. Okay? Because the first element in S will be the largest one. So let's store this in X. Let's store this in X. And then I will multiply S with X. Okay? So the first digit will be multiplied by 100. The second digit will be multiplied by 10. The third digit will be multiplied by 1. But there's one additional thing that I need to consider. And that is the fact that S is a character string. It does not contain the number 4 here. So this is a character string. And I need to convert the character 4 to number 4. Okay? If you remember the ASCII table, the numbers go from 0, 1. Let's actually pull out the ASCII table again. And let's look at the numerical representations. The number 4 has the integer representation 52. Alright? So if I take any digit, in this case the number 4, or it could be any other digit, I subtract it from the numerical representation of 0, which is 48. I should be getting the numerical value of that digit. As a result of this, I will get the number 4. So you're looking at the difference from your digit to the digit 0. Okay? Is that clear? All right. So I will subtract from the digit 0. So the digit 4 will be replaced with the number 4. Digit 5 will be replaced with the number 5. And the character 6 will be replaced with the number 6 using this operation. All right? And then dot multiply with x will multiply with with hundreds, tens, and ones. And I will take the sum of those and return it as output from this function. Let's try it. Int str to num 456, and it's giving me the correct result. So I'm taking a string and generating a number. Okay? Any questions? So this is sort of similar to what's going on behind the scenes when you call the str to num function. Matlab additionally takes care of the dots, the scientific notation, the brackets, and so on. Okay? So we didn't go into that much detail in our example. All right. So we first index s to extract this portion. So it's a string, and then call the str to num function to convert it into a number. If you don't really want to figure out where your number is located, but you know the word before it, you can find the length of it, and then go from that length L, and then you count 8 more digits to get the same result. So these are sort of not as useful. The most appropriate one is to use the format string itself. Using this scanf function, you would use the same format string that you use to generate the string itself. So it's sort of the opposite of printf, and the %f will capture this number out. Okay? And you will get 63.5 as a result. More examples. The second out argument will give you the number of items that scanf was able to extract out of the string. So I have a single %f. Matlab will parse out multiple floating point numbers, and it will give me 2.7 and 3.1 out of this example. I believe I didn't really, this example is not accurate because I'm missing this additional floating decimal places that are shown in the output. So this example is not correct. It should just be 2.7 and 3.1. All right, so in your format strings, if you do not use %c stands for capture a single character. If you do not use %c, all the spaces will be ignored. All right? So when you extract %s, meaning you are extracting strings out of the larger string, then all the spaces will be ignored, and you would be getting a single long string. All right? If you use %c, you would be extracting individual characters. And the count tells you how many times this format string was able to match the larger string. A function that's more powerful, the more powerful than scanf is a text scan. Again, you provide a format string, and then it will give you a cell array of the items that it was able to parse. So in this example, I have my string containing numbers as they are printed. So these are not really double data type. It's a large string that contains numbers. It could also contain alphabetical characters. And then I'm using text scan with %3.1f. So that says I'm parsing out floating point numbers. Each of those floating point numbers will contain, will sort of span 3 characters. And after the decimal point, I'm looking for a single digit. All right? Following that, I'm going to match a single integer number. So %d stands for integer, a single one of them. And then star means ignore it. Do not return it as part of the output. All right? So we'll take this format string and map it on top of your original string. So %3.1f, I will only look at 3 characters and only 1 decimal point after only 1 digit after the decimal point, so that will be 0.4. And then I will ignore a single digit. I will ignore the number 1. And then repeat that. You have 8.2, ignore number 4. 3.5, ignore number 7. 6.2 and 9.2. All right? So you take your format string and then you lay it on top of your original string. You walk through your original string and you try to parse out a floating point number and the single digit. Okay? All right. Here's another example where I have a single string that contains 3 lines. So this number 10 is the new line character. When Matlab prints it, it will move on to the next line after the end of each line. And each of these lines are formatted in the same manner. You have a date, levels 1, 2, or 3, and then a number, another number, some infinites, and not the numbers can also occur, and followed by a string that could be either yes or no, followed by another complex number. Okay. So I will take the first date and capture it with a single %s. I will capture the levels with another %s. I will capture the floating point number with %f. If you have a number following the %f or %d, it represents the size of that data type. So I'm capturing a 32-bit floating point number. Normally, double numbers are 64-bit. I'm capturing a 32-bit floating point number. So the number that Matlab will extract, it will store it in a data type that is a single number. And you can look at that in your workspace. Instead of a double, it will show a single number. It has less precision. It cannot store as many numbers as a double number. Okay. And then the next number is being parsed using the %d8, which is an 8-bit integer. %u will parse a number in scientific notation. And then floating point number, %s, which will match yes and no's. Finally, another %f, which will parse the complex number. Since I have more than one line, I will get a cell array that contains an element for each of these % signs that I'm parsing out. And each of those elements will contain 3 matches, 1 for each line in the original string. So the C cell array 1, the first element will contain all the dates, the second element will contain all the levels, and so on. Okay? So if you have a file that contains multiple lines that all follow the same formatting, you can use a single text scan function call to parse out all of the individual parts in your file. All right, let's say we are only interested in, let's say we are not really interested in the word level, and we only want to get a number from that location. So we want to ignore this word level. In the previous example, we used %s to capture the entire word. And as I mentioned before, if you have anything that does not follow a % sign, it is matched up exactly. So this level will be matched up with your original string exactly as it is, which will effectively skip all of the level words in your original string. And you are capturing the %U8, which will capture these 1, 2, 3 numbers. And you will get the numbers 1, 2, 3, and you are never capturing the word level. All right? If you would like to skip until the end of the line, so let's say we are only interested in the dates in the first item on each line, there's a special usage where you enclose in square brackets a caret symbol and a new line. So that stands for anything that is not a new line. So a caret usually represents anything that's not in string operation, in the string search functions. Okay. So this will match a string followed by anything that's not a new line. So it will match with this date followed by anything that's not a new line. So it'll go all the way to the end. And when it hits a new line, that's the end of the match. Okay? And then the next match will start. A string, anything that's not a new line, stop the match. And then another string, anything that's not a new line, and then end of your original string. And then the star character tells Matlab to not return that as part of the output. So it will match this, but you're not interested in it, so it will not be returned as an output argument. All right? So the result of this function call will be a cell array that contains 3 elements, and they will be the dates parsed out of this string. Okay? Any questions? All right. So let's work on an exercise where we will parse out atoms from a protein coordinate file that lists the coordinates of atoms. So there are some special words, and the actual coordinates are right here. So X, Y, Z coordinates for each atom are given in each line. You could try to match the entire string using the atom keyword and then a %d to capture this number, a %s to capture the name of the atom, another %s to capture the name of the amino acid, and so on. But eventually you will only need these 3 %s, which is returned as the 6th element of the return cell array. Okay? So you will get C6 will be that, C7 will be the Y coordinates, and C8 will be the Z coordinates. So here in this example, I'm skipping everything up to that point. So I sort of counted and figured out that the coordinates start at the 32nd character on each line. And I will put a star and skip 36 characters. And then capture 3 floating point numbers, which will be the X, Y, Z coordinates, and then skip to the end of the line. All right, so that will give me only a cell array with 3 elements that contain the X coordinates, the Y coordinates, and the Z coordinates. The cell to mat function will take a cell array and generate a numerical vector. And this will be the numbers that you extracted as X, Y, Z coordinates of the 4 atoms shown in this string. Okay? So this example, this exercise shows how you will solve the homework problem that I will post on the web, where you will take a large file as shown here. CRN. So you will take this file and you will skip everything until you get to the atom lines, and then you will extract these coordinates and return the centroid, which is the average XYZ coordinate for this protein. Okay? All right. So far we've only worked in Matlab, and we only did strings where we use single-quoted variables or single-quoted values or variables that contain strings. For larger applications, you would usually have files that you would save your content in. Okay? And you would want to reopen those files, read them into Matlab, and then parse them. Okay. Similar to how I saved the comma-separated file from Excel to a file on my desktop, now I would want to take that file and read it into Matlab. There are several functions in Matlab that help you collect and read data from external files, such as Excel sheets, comma-separated files, and so on. But in some applications, you may not have very well-formed data that are not in Excel sheets, but that are in text files, such as the example that I showed you on the web, where you have a PDB file, which is not an Excel sheet. Okay? So in that case, you do need a function that will parse out only the portions that you need. We've already seen the load and save functions that load a Matlab variable or save a Matlab variable into a file. The type function will take a file name and just print it in the command window. So if you have a file named test.txt and you say type that text.txt, Matlab will print the contents of that file in the command window. And we will see fprintf can be used to print into the files. XLS read, XLS write will read from an Excel sheet and write into an Excel sheet. But you may need to have Office or the appropriate toolbox installed for this. In the past, students have had trouble using these two functions on Macs. So the lower level IOs is where you operate on the files in a more detailed level. And those are, so there are some concepts that you need to be familiar with. Whenever you open a file, you sort of keep a handle to that file. And that handle is an integer identifier. So you will have a file name that identifies the location of that file on your computer. And then when you open that file in Matlab, you get a number that represents that file. All right? So let's do an example here. We will use the fopen function to open a file. So let's see if I have. Okay, I'll open the 1crn.pdb file that's in the current folder. And I will store the result of opening this file into the variable f. So the variable f contains the number 3. All right? Now I can read this file, fread f, and it goes and takes the open file. I provide the identifier, which is f, or I could also say 3, but which is not recommended. Always use the variable because the number could be different. And then it reads the contents, prints them out, or you can also store them in another variable s. So the first time that you read it, there's a cursor, there's a hidden cursor that corresponds to the current location in the file. fread read the entire file, the cursor went to the end. The next time you read, there's nothing more to read, so you get an empty string. All right? So let's close the file, reopen it, and then read it again. But this time I will convert it to a character array. Okay, so you get the contents of the one CRN as you would see in the editor. All right. Okay. So these, you can look up these functions in the help window. fread will read characters from the file. fget will also get a string from the file. So you can use fread to read the entire file in one shot. fget will get a single string. fgetl will read a single line. fscanf can be used to read a formatted string, similar to using the scanf function. If you want to change the location of the cursor, let's say you have a file that we opened. When you first open it, the cursor will be at the beginning. As you read, the cursor would be moved to the end of what you read. You can use the fseek and fseek function to move the cursor back or forward, and then read a new part of the file. The ftell function will tell you where the cursor is. So ftelf will tell me where the location of the cursor. Since this file contains 49,000 characters, or roughly that many characters, the cursor is at that location. Let's set the cursor to the beginning. But first we need to figure out how to use the fseek function. Offset and origin. So we need to see. All right, let's close the file and reopen it. Now, if you ftell f, you will see that you are at that location. All right. All right, so the general steps in working with files is that you open the file, you read the file, or you write into the file. Sometimes you may not want to delete everything from the file, but you may want to append to the end of the file, and that will make. If you want to do that, you need to open the file with a different, not with a different letter. So fopen function will take a permission string. R stands for reading, W stands for writing, and A stands for appending. Closing the file, you would provide the identifier of the file and close it. If you say close all, it will close all the open files in your Matlab window. These are additional ways that you can open files. Writing into files. In this example, I'm appending to the end of the file instead of deleting the contents. So if you don't provide A, but you provide W, when the file is first opened, the contents will be deleted, and then you would be starting over writing into that file. Okay? So it will start to the beginning of the file, getting rid of everything else that was in that file before you opened it. And then fprintf will work in the same way as working in the command window. But now instead of printing into the command window, I am printing into the file. And the first argument will be the file identifier that I am printing into. And you would obtain that file identifier using the fopen function. So after you write these lines of code, the contents of the temp.txt will contain, this is a string, and then the numbers 1, 2, 3. Make sure that you close the file when you are done. Don't leave any files open in your Matlab. If you do leave them open, then if you go to the Windows Explorer and you try to delete that file, Windows will give you an error saying that the file is opened by another program. You can go back to Matlab and say fclose all to close all the open handles. Okay. So more detailed steps. You open the file. After you open it, you make sure that the file was successfully opened. If you try to open a file that does not exist, the file identifier will be -1. If you successfully open it, it will be a number that's greater than 2. And then when you are reading files, you can loop until the end of the file, read line by line, and after you read each line, you may want to extract portions of that line, such as the atom coordinates, and store it in a matrix. And then at the end, you would attempt to close the file. Usually, you would not check whether the file was successfully closed, but it's a good habit to additionally check that the file was closed. Okay, so this example shows where I open the file named filename, and I check whether it was successfully opened. If not, I display an error message. And if it was opened successfully, until I get to the end of the file, I read a new line, and I perform some operations which are not done here. And then when I'm done, I close the function. So the important step here is that I have a while loop that loops over each line and performs some operations. Okay, so you would loop over each line of the PDB file and extract the atom coordinates. All right? Any questions? And the answers to these exercises appearing in the lecture notes are available online.
Hopefully.